Welcome to the HDS Tech Tour Workshop. Today we will be speaking about a topic that has been gaining strong traction in the storage world. Data is what keeps a business going, and organizations are taking strict measures to ensure their data is well preserved and protected. However, as we all know, data is continuously growing, and the question is, how do we use the data that we have and turn it into valuable information? This information can then be applied back to the business to create performance, reduce costs, and improve revenues. Welcome to the world of analytic-driven storage management. Let's explore further. We will take you through the components that make up analytic-driven storage management and share with you examples of how analytic-driven storage management is used to solve typical challenges faced by organizations to highlight the importance of analytics and the potential it brings to your business. During the second part of the presentation, we will run through a case study of a multimedia company that offers real-time and video on-demand contents to its network of subscribers. We will explore some scenarios and highlight some of the more critical challenges that they were facing and how working together with HDS solved these concerns. This case study will be followed by a short tour of our demo lab where we will show you a live demonstration of analytics-driven storage management in action. This should be a familiar image to all of us. I am sure all of us here have taken flights for business and leisure, but how many of us actually know the history of aircrafts? Aircraft technology has been evolving and is still evolving as we speak. The first successful airplane was invented and built by the Wright brothers in 1903, and it was an amazing feat because nobody ever imagined that such a heavy machine can be airborne. On the outside it might look simple, but an aircraft is made up of hundreds of thousands of parts, all working together to ensure we get to our destination safely. The complexity of ensuring all parts work properly and alerts are immediately flagged out lies in real-time analytics and constant monitoring. Do you know who has the most important role in an aircraft? Yes, it is the pilot. A pilot can only get his or her license after having 1,500 hours of flying time. And before even stepping into the cockpit, a trainee has to attend courses and train on flight simulators. Why? Because he needs to have an in-depth knowledge of an aircraft to be able to guide the plane to its destination and react to situations to ensure safety. There are thousands of parameters, indicators, and switches in the cockpit. Without proper training, a pilot will not know how to react to situations. And, by the way, can you guess what aircraft model is in the picture shown? It's a Boeing 747, which was first released in 1969. You can see how complex the controls in the cockpit are, and only with the proper skills and experience can a pilot manage to fly such a plane. Similarly, in our IT industry, can we react and respond fast enough when a problem occurs? An organization's IT environment is complex and consists of many components, from storage to computer, network, applications, and operating systems. Are we able to focus on finding the root cause accurately? As a matter of fact, IT is as critical as an aircraft, as a business relies on IT to function well. Any failure or downtime will cause direct impact to the business. Loss of money and reputation is something that most companies try their best to avoid. When we talk about improving the IT delivery to the business, we focus on reliability, availability, and accessibility. However, most times we use the technical point of view instead of looking at it from a business angle. In order to justify the investments, or when requesting budget for enhancements, the IT department should deliver a more business-oriented proposal to the management. A business-centric IT proposal will be more readily accepted by management or board of directors because they see the direct value IT brings to the organization. There are three things that management is expecting from IT. They expect a simplified, automated, and smart IT infrastructure. From a business perspective, it means imperative, integrated, and intelligent to them. It helps them to ensure service level, and simplify the operation of workflow. Even if there is an incident, the system can diagnose the issue and pinpoint the root cause. That minimizes the risk to business. According to IDC, 45% of IT staff time is used on routine operations such as provisioning, configuration, maintenance, monitoring, troubleshooting, and remediation, whereas only 21% is dedicated to innovation and new projects. In your experience, you probably find this to be true. Most of the time, we are simply too busy performing the day-to-day operational tasks that we do not have much time to think of ways to improve the IT infrastructure and process. How can we turn this statistic around? Eric Bergener, IDC Director, said, "These routine operations can be simplified with automation." How easy is it to automate your infrastructure management? Do you do it step by step, all at once, or part by part? We know for a fact that there are many day-to-day tasks performed by IT teams, from network, application, and platform to storage, backup, and development. These tasks are usually repetitive and time-consuming, leaving limited opportunity to focus on improvements or new projects. However, with automation, these tasks, such as zoning, storage provisioning, can be simplified and require less human intervention. Automation can greatly reduce manual errors and reduce maintenance and operational costs. With ease of management and deployment, there is a higher possibility to introduce self-service for general tasks to project owners or functional heads. A typical IT environment consists of many storage silos, and this leads to management complexities and imbalanced utilization due to certain projects requiring specific resources. When a certain asset reaches end of support or end of life, migrating to newer assets requires downtime and advanced planning. How do we mitigate this typical business challenge? The most effective way is via consolidation and virtualization. Having all data assets under a single management will greatly reduce management complexities and enable an overall view of your storage infrastructure. You will then be able to see all the storage silos as a single pool of storage, giving you the flexibility to allocate storage resources as required. With virtualization, removing legacy systems from your infrastructure requires minimal or no downtime, as data can be migrated online anytime. After you have performed simplification and automation, what's next? IT provides a service to the business, and there usually is a pre-agreed SLA to meet. In order to define the SLA for each application, you first need to identify and categorize what applications are running in the systems and how critical they are to the business. This is part of aligning business to IT. Once the SLA has been agreed upon, how do you ensure that you accurately monitor the service levels and quickly take remedial action when they are not met? HDS provides a solution which can monitor application service level for both performance and capacity in a single pane of management. A graphical view will show the statistics at any given point of time, and IT can quickly respond if any issue arises. The solution also helps with capacity planning based on application needs, ensuring that you do not over-provision your storage. Another great feature is bottleneck identification, which allows you to quickly resolve issues before they become critical. If you are not physically present in the office, do not worry, as the management console can be accessed from virtually anywhere as long as you have an internet connection. You can monitor your application service levels and storage system health remotely, giving you peace of mind. Remember the Boeing 747 cockpit we saw in the earlier slide? Just like the aircraft industry, IT has also gone through an evolution. Simplicity and efficiency are the keys to ensuring business success. What aircraft model do you think this is? It is the 787, which came into service in 2011. Don't you think your IT environment should look more like the 787 than the 747? How do you think a pilot should react when faced with the scenario above? Should he land immediately? Or should he just shut off the engine and stop mid-air? You know what would happen, and it wouldn't be pretty. What happens if a similar scenario occurs in your IT infrastructure? Your data and service is equally critical, and just like an aircraft, you cannot afford to just stop service at any point of time. Fortunately, in the IT world, we have something called a DR, or standby site, for us to resume operations. However, most of you will be familiar with the procedures before, during, and after a disaster. First of all, you need to have identical hardware and software on the DR site. When a disaster occurs, you need to make sure the failover procedure is done successfully and ensure all services are up. When the issue at the primary site has been rectified, you need to ensure any updated data is synchronized back to primary before doing a failback procedure. The entire process involves downtime, and most times the Board of Management does not appreciate even the slightest disruption to their business. Just like in the airline business, if an airline has problems with their system and could not take bookings, they will potentially lose business as customers will just proceed to another airline. Okay, let's say you have invested in a DR site. Is it possible to extend the service level and increase data availability with our investment? Yes, you can. A DR or standby site does not mean that it should be waiting for a disaster to happen in order to be functional. Some application owners require zero downtime, and some need to access data simultaneously across data centers. These requirements are usually hard to fulfill, and not many solutions out there can provide for such a need. However, the HDS solution comes with Global Active Device, which allows active-active and concurrent access to your data centers. It is able to increase performance and improve resource utilization by performing workload balancing between data centers. The Global Active Device is the foundation that enables two sets of hardware to form a virtual storage machine. Hosts can access both storage systems across the site, and this facilitates high availability and a non-disruptive failover. The Global Active Device not only provides uninterrupted service, but is also flexible. Maybe you only want to enable this capability for more critical data sets which require higher uptime. All writes on each site are replicated synchronously, while the reads are done on the local storage to maintain performance. In the event of a disaster, failover is transparent to the host, and there is no additional configuration required. With Hitachi's unified management, OPEX is minimized due to simplified management, automation, smart management, and an always-on architecture. Reap the benefits of one single management software to manage, monitor, and configure your infrastructure. Managing your entire architecture is made easier with root cause analysis, bottleneck identification, and noisy neighbor detection that comes with suggested action to take. This slide highlights the HDS vision of unified management across all Hitachi storage systems and data types, whether block, file, or content. We are proposing a broader definition of unified storage than what has been traditionally used in the storage industry. The first unified storage solutions were driven by a market need for combined systems for smaller organizations who did not have the storage volumes, IT resources, or budget to acquire and manage separate platforms for block and file data. In other words, the traditional definition for unified storage was focused on managing file and block on these general-purpose lower-end storage platforms. Complementing this unified storage approach, we see unified management as being the ability to really abstract the complexities of the underlying storage environment into a truly service-oriented model. This is basically the cloud principle. We need to be able to manage storage overall as a service to our consumers, regardless of the nuances of the underlying physical devices that are serving up the storage. And this requires a truly unified management approach. 1. Unified management and control across all the tiers of storage in our portfolio, enterprise and modular, along with external virtualized storage environments. Unified management across all storage paradigms, block, file, and content. And third, unified management across functions encompassing all the different management tools that we need to control, analyze, optimize, and protect the data, along with a unified intelligence layer that adds the critical functions to become more service-centric, including storage device level management for mission-critical business applications, chargeback reporting, and a centralized dashboard for complete insight into application service levels, storage system health, and capacity utilization. Let's have a look on the case study. We will explore different real-life scenarios that touch on how the HDS solution works in the real world and how it can help you drive operational efficiency while ensuring you are able to survive critical situations like engine failure during your flight time. For the purpose of our discussion today, let's imagine there is this company called HTV. They are a leading internet television network provider that delivers round-the-clock unlimited content to their members anytime and anywhere. Their business model is pay-per-view or on-demand basis. Their business objective is to drive and capture pay TV market share with a committed service level. However, in the past 12 months, HTV is experiencing high attrition rates due to a number of unforeseen challenges. Starting from the hardware failure that caused 2 service outages, their customers also complain about slow video streaming, and this was eventually identified as caused by unpredictable high-frequency access of seasonal video during Christmas. HTV's IT team had trouble identifying the root cause of this issue, and they are being blamed for only being able to identify the root cause with a fix after a decade. Their data center site went through a planned yearly power maintenance, and this also caused HTV to miss their service commitments. The DR facility that they invested in has a high running cost, but unfortunately they are not able to fully utilize this investment. These complexities have caused an excessive burden to the company, and business has been badly affected. HTV has 3 regional data centers situated across the United States, Europe, and Asia Pacific to support their business. Workload is distributed among these 3 data centers, and their biggest user base is in the U.S., where 1 million subscribers are using their service, while Asia Pacific has around 100,000 customers. HTV started their data center small in the beginning and has employed the same reference architecture in these 3 sites, all of which can be scaled non-disruptively. Let's focus on the Asia Pacific region, where their primary data center is located in Chai Wan, Hong Kong, with Tai Po as their secondary site. In the solution blueprint shown above, an active data center is deployed across 2 sites with a distance of less than 100 kilometers between them. A hypervisor metro storage cluster is created for production workloads and applications. This architecture was built with high availability and disaster recovery for enterprise storage environments located across the 2 sites. Application services can be set up to run active processing of shared data with all interfaces to the storage system always active, and the system synchronizes writes across the entire storage system. An integrated administration and monitoring tool is deployed to ensure performance and availability meets the required service level. We will be playing a video clip during the demonstration for your viewing pleasure. Okay, let's look at Scenario 1. HTV receives provisioning requests daily for new application rollouts. A storage volume can be easily deployed through a quick 3-step process using tiered storage provisioning based on storage service catalog with auto-SAN zoning. Volumes are automatically assigned and attached to the destination host. In order to provide quick data recovery, a point in time like snapshot technology with scheduler is set on the newly created volume, creating 3 copies per day at 9 a.m., 12 p.m., and 3 p.m. In case of data corruption, a closest data point can be quickly recovered and business can resume with minimal disruption. A dashboard view shows the provisioned and protected capacity at a glance. This would address HTV's challenge on operational complexity and high attrition rate due to excessive burden. In Scenario 2, imagine if a failure happens to the storage subsystem in the primary data center. Storage service will fail over to the secondary site and data access to the primary storage becomes unavailable. Event console shows that the primary storage subsystem is down. However, if you notice, the video clip is still running with no disruption and no service impact. With the active-active storage architecture design, business service is maintained at 24/7 operation mode. With the HDS Analytics tool, a root cause can be quickly identified using the end-to-end infrastructure view. With this capability in place, we can safely say that there will be no service interruption or downtime during storage failover and failback. Our storage solution also supports 100% data availability, so there is an additional protection guarantee for your data. If you look back at the challenges faced by HTV, this scenario helps resolve two challenges: disruptive hardware failure causing TV service outages, and high running costs with low utilization of the DR facility, since workloads can be run on both data centers simultaneously. The third scenario shows the hassle and downtime suffered by HTV during past incidents. In this traditional environment, an active-passive data center is set up with data replication. We will simulate the same storage subsystem failure as in demo scenario 2. You will notice that after failure, the video is interrupted and an alert will pop up in the monitoring console indicating that service is down. During this time, the IT operations team needs to trigger a DR recovery procedure to resume service. It takes about 60 minutes downtime to get the video back online again and resume playback. This scenario causes service downtime. Therefore, an active-active design with 0 RPO and RTO should be the foundation of every data center design. In scenario 4, we will show you a planned workload migration performed in an active-active environment. For HTV, they failed to meet service commitments due to their yearly power maintenance work. In this scenario, before the planned power shutdown, a long-distance V-motion is triggered to move the workload from primary site to secondary site. The hypervisor and the Kung Fu Panda movie are migrated smoothly to the secondary site without interruption. Once all workload has been relocated to the secondary site, a proper shutdown on primary site can be performed. No notifications are required to update customers of this impending situation, and it translates to good news to the IT support team. Demo Scenario 5 will simulate an ad hoc I/O overload situation, similar to the unpredictably high-frequency access of seasonal video experienced by HTV. A high I/O latency plus excessive workload will trigger a threshold alert in the management console, and with the Sparkline view, one can identify the root cause by comparing the baseline versus the current workload. From a different view, drill down to subcomponent disk level, and this shows you a more detailed view of the RAID set and where the performance bottleneck is happening. To quickly and easily remediate this issue, an auto or manual online data migration of the identified volume to a higher performance disk, e.g. flash module drive, can provide the much-needed boost in performance. When demands resume to normal, this process can be reversed. In summary, a smart analytic-driven storage management tool with active-active design is mandatory to ensure business success. Based on the case study scenarios that we have just shown you, you can see that our solution helps to address all of HTV's business challenges with the benefits of 3A: always on, amazing customer experience, and more importantly, the solution is affordable. If you would like to have more detailed information about how HDS can help you, simply email to us at info.hk@hds.com. Thank you.